This is part 5 of our mentorship, and really it's what is the total impact of these mycotoxins and how do they affect all of the other systems? Because it's not just the gut, even though that is kind of the center and focus of our discussion. And I do believe it is the primary driving factor of a lot of the neurological issues that we see in these kids. There's a lot more to the picture than meets the eye. So you've seen this image before, and now I'm stating it as this is what it's like to try to treat a child when you're missing mold exposure. And the reason why is you're swimming upstream with all of these systems oftentimes simultaneously impacted. And you come along and say, well, I'm going to support the detoxification, except their innate detoxification pathways are grinding down to a halt. I am going to pump this kid full of folate, which I'm a huge fan of. I think, using leucovorin and folic, high doses of folate are helpful, but without us asking, well, what is causing the cerebral folate deficiency? And you can see there's mitochondrial issues on and on. So you have to really stand back and instead of just jumping into treating whatever you see on an organic acid test or whatever else, stand back and say, what is going on? What is causing all of these issues at the root level? So with that, let's start off with detoxification. So T2 is trichothecenes, one of the mold toxins that are very common in the exposure. And what you see in these two studies is how trichothecenes and other mycotoxins can ultimately disrupt glutathione. And for all of you, I'm sure you know glutathione is the master antioxidant, right? The liver depends on it for detoxification. Ultimately, it's necessary to stabilize so many different cell lines and minimize the oxidative stress that they have. But it's so easy to say, well, oh, these kids have detoxification errors. I'm just going to pump them full of glutathione because that's what's going to fix the problem, which in the long term, I've seen not be so fantastically helpful. And in fact, some of the kids go into a flare when you do that. Conversely, what I have found, you take care of the exposure, control the exposure, fix their gut, get their guts operating, and all of a sudden you just see these children's ability to detoxify improve. And how you know that is their vitality is excellent, their mood is excellent, their mental clarity is excellent, their color, and just their appearance all improves, which is all a sign that everything is going in the right direction. And if you ever do follow-up testing with organic acids or whatever else you use, you start seeing that a lot of those detoxification markers going in the right direction. NRF2 is one of essentially the most critical regulators of the antioxidant pathways. And as this article states, the most common and well-known mycotoxins ultimately influence the expression of this NRF2, which has all kinds of downstream consequences. Now, what is NRF2? So NRF2 is really this, if you want to say, genetic master regulator that ultimately influences pretty much all other detoxification antioxidant pathways. So NRF2 controls the genetics and transcription of glutathione and ultimately these redox states. It influences the functioning of phase 1 and phase 2 detoxification of all kinds of different compounds. And as you know, there's phase 1 and phase 2, and then there's phase 3. But those are kind of the two critical parts of what the liver needs to do to effectively detoxify. And this is mycotoxins, estrogens, all kinds of the other toxins that we are exposed to from in our environment. It influences the cellular defense mechanisms around xenobiotics, which are all of the different toxins we're exposed to, and the secondary oxidative stress that they cause. So you can already start seeing the picture of you've got a kid who is living in mold and large amounts of mold, and you completely miss it, and now you're charging ahead, giving them sulforaphane and giving them curcumin and giving them this, except at a core level, you can make a pretty strong argument that the child's innate ability to produce the antioxidants they need to function and detoxify is not there. What about the mitochondria? So, if any of you want to, you know, go deep into this conversation, this is a wonderful book that I would recommend you read. And at its core, what Dr. Fry states is essentially the mitochondria are behind all human disease. And when you think about it, and what mitochondria do for our bodies, it actually makes sense. I mean, there is no organ system, there is no cell line, there is no physiological process within the human body that is not touched in some way, shape, or form with the mitochondria. And when the mitochondria get hit, essentially all other systems are impacted in a large way or small way. And it's not just the mitochondria, it's our entire metabolic kind of pathways. Because, yes, the mitochondria are down here and they're responsible for producing ATP, but you've got the Krebs cycle, you've got fatty acid oxidation, and everything that goes into that. This is a summary of several studies that I found where you can appreciate the significance of what these mycotoxins are doing. So part of why, I shared with you that one of my primary screening questions is, hey, parent, which of you has brain fog or you feel exhausted all the time? And usually there's one person that raises their hand. When we look at these children who have gross motor delays, who are exhausted all the time, who attempt to run and they poop out, all of these are a sign of mitochondrial anomalies. Now, is it that their mitochondria have shut down? No, because then at that point, heavens forbid, we pass away, right? So it's not as dramatic as that. But you could see it in these kids. They're just exhausted. They're run down. They're tired. They lack vitality. They lack stamina. They lack endurance. And we see it in sometimes the parents. That is all this. So mitochondria, the mycotoxins can deplete or disrupt the membrane potential. And what is the membrane potential? The membrane potential is ultimately what the mitochondria use to produce ATP, right? Because all of this that you're seeing, right, all of this hydrogen being pumped out, everything that is going on is basically to create a gradient, right, which then allows the electron transport chain to function, which then allows ATP to be produced. With that, this complex 1, 2, 3, 4, 5 is part of the electron transport chain, which is essentially the conveyor belt that the mitochondria use to produce energy, produce ATP, and you see that's compromised. And you can see that it goes beyond that, where the cell in which these mitochondria are also in is damaged, because when there's mitochondrial damage, that actually triggers the cell. If enough of the mitochondria within the cell are damaged, it triggers the cell to actually destroy itself because that cell is no longer healthy. With that come major disruptions in metabolism. So for those of you that get these kids where you don't see any signs of fungal imbalances or organic acids, right? The organic acids look fine, but you see signs of mitochondrial disruption. You see signs of fatty acid errors, right? With one of the fatty acid or several fatty acid markers being elevated. That is all a sign of some kind of toxin. If it's not the mycotoxin, something else is at play. We get massive oxidative stress. And ultimately, at a certain point, that oxidative stress causes so much cellular damage, which then triggers inflammation. And with that, it's not just cellular damage. You get changes to the lipids, right? So it's almost like, imagine fat going sour, right? So there's lipid peroxidation, there's damage to the DNA, and then there's the cell death that comes. And all of this is because of the mitochondrial dysfunction that's there. If that wasn't bad enough, this biogenesis is essentially the mitochondria's ability to repair itself. And part of what happens with these trichothecenes is that it actually starts disrupting the genetic repair mechanisms that these mitochondria use to repair themselves. So not only are they getting hit, not only are they being damaged, on top of that, their ability to actually heal themselves and repair themselves is compromised. And if you look at this as why the hell would these mycotoxins be doing this? Well, mycotoxins are there to decompose and repurpose physical organic matter, right? So then it would make sense that these mycotoxins want to shut down any and all organic processes, right? They want to shut down life because when it shuts down life, that is how it's able to reprocess, right? Compost life. So it makes sense in terms of why it's happening and why all of this is taking place when you just think of it at that kind of biological level. And this is some of what you would see. So these are mitochondrial markers. You see these elevations. And, a lot of times when people look at this, they're like, oh, I'm going to put this kid on some kind of supplement. And I think these supplements, these cocktails like Spectrum Needs and, whatever else are great. But first, you need to take care of what is causing the issue in the first place. And now, as I'm taking this approach, what I'm finding is 50% of the time the kids don't need the supplements. And then the kids that do get the supplements, they thrive like gangbusters. Conversely, before I would put the kids on whatever, mito cocktail that I had that I liked at the time. And I'd say 30–40% of the time kids would get better. And 60 to 70% of the time, these kids were just as bad, if not worse. And I couldn't understand why until I started looking at this picture and understanding what this picture meant. What's also fascinating is these mycotoxins can also hit this carnitine O acetyltransferase. What does that do? Ultimately, that is responsible for producing this acetyl-CoA, which we need for fatty acid oxidation. So you get multiple hits at the same time. You get a hit to the mitochondria and their ability to produce ATP, but you're also getting a hit to these other pathways that are necessary for feeding essentially fuel into the Krebs cycle for that. Now, what happens when the mitochondria are not running optimally? What takes place? Well, to understand that, first we need to ask, well, what are the organs that are more susceptible? Because you see it in the muscle, right? The muscle is a metabolically sensitive organ. And if mitochondrial function is not optimal, you get kids who just poop out really easily and they run for 2 minutes and they tire out. But what happens here, right? Because we know that the brain is a metabolically sensitive organ. So it's interesting to look at the studies where now these are people with frank mitochondrial disease. So it's not just a little bit of mitochondrial insufficiency. This is like frank, messed up mitochondrial disease. And what you see is 60% of these people have significant, not just a little tiny bit, they have significant psychiatric illness. And then you see in the bottom study, researchers have found evidence that altered mitochondrial function is related to that MDD is major depressive disorder or bipolar disorder. So you start getting this picture of how big of a role these mitochondria are playing in cognition. And then when you ask, well, how do neurons do what they do, right? How do neurons function? How do neurons fire? How does the neuronal to neuronal signaling take place, right? All of these fancy, signals that they're sending back and forth countless times. How does that all happen? Mitochondria, right? Neurons just don't shoot action potentials back and forth, right? As you see over here, mitochondria are essential for neurotransmission, right? Communication, short and long-term neuronal plasticity, and cellular resiliency, and ultimately their ability to adapt. And everything from the ion gradients to clearing of the neurotransmitters, the movement of the receptors, everything is dependent on the mitochondria. So imagine what happens when the energy supply of these very energy hungry cells starts diminishing. You get all kinds of weird things happening. Now, there's a more interesting piece of that. So it's not just, oh, the neurons aren't firing, as properly as they can. If you dig into it further, what you see is there's a part of the brain, the prefrontal cortex, right, that is responsible for managing a lot of the sensory input that we receive. Now, why is that important? So, in the prefrontal cortex, there are these GABAergic interneurons. And these GABAergic interneurons are really important for controlling this excitatory signal. So imagine there's all kinds of information coming in. The prefrontal cortex is really important to help regulate that. And you've got these GABAergic interneurons that really are kind of the traffic cops of that. It turns out that of all of the neurons, these paravalvular interneurons, these GABAergic interneurons, are the most sensitive to energy disruption. And when there's a mitochondrial dysfunction, it causes impairment of complex information processing. Now, keep in the back of your mind, and we're going to circle back to this a little bit later, everything that we've talked about with histamine, right? So when there's excess histamine, sensory pathways are disrupted, right? So you've got vestibular issues, you've got auditory processing issues, you've got all kinds of other things that are happening. And simultaneously, the part of the brain that is actually taxed with managing that sensory information is also disrupted. And they go on to this other study talks about how deficits in the function of these interneurons are associated with behavioral deficits in not just autism, but schizophrenia. So you start getting this picture of it's not just you got a histamine issue. It's not just we've got an issue with the microglia, but now the mitochondria and all of the downstream cellular neuronal functions that need to be in place are hit. And part of what I want to impress upon you and why I want to impress upon you this is think about how hard it will be to get these kids well if you don't understand what is triggering all of their issues. And even if you were to get to a place where you say, oh, well, this kid has some mitochondrial markers, so I'm going to put them on CoQ10 and whatever else to address the mitochondria. But you miss the mycotoxins that are disrupting the energy production that is then causing the cellular issues. But those mycotoxins are also triggering inflammation. They're also triggering a cascade of other events simultaneously at the same time. And this is what makes mold medicine complicated until you really start understanding the finite details of why everything is happening and then going a layer or two below and treating that root cause to then address all of the superficial issues that we see. Add to that this finicky little organ we call the adrenal gland. And very few people pay enough attention to the adrenal gland. Except when you look at what the adrenal gland does, and this is a book from my mentor, Kamir Hedayat, the adrenal gland's primary role is really to ensure our survival. If you distill it down, like what is the primary purpose of the adrenal gland? It's to help us adapt and to help us survive. And when we need for it to kick up a ton of cortisol and whatever else to help us in that moment of fight flight, but also to help control inflammation, to help manage a host of things, including all of this. You don't need to memorize all of this. The main reason why I included this diagram is just to impress upon you how much of a role cortisol plays, from managing glucose metabolism and glucose levels to addressing the immune system, on and on and on. And when you just sit back and just stare at, this or any other diagram, and you look at just the singular role of cortisol and how much it is doing at one time, and then step back and say, well, where is all of this coming from? Oh, yeah, it's the adrenal glands. The adrenal glands are where our cortisol is produced, along with all the mineral corticoids, right? Along with the testosterone. And then you've got on top of that, its ability to produce epinephrine in case there's a stress response. You get to a place where you start really appreciating the role of the adrenal glands and how important they are in our everyday state of functioning and thriving and so forth. So, why are we talking about this when we're talking about the mitochondria? This is a 2006 study, which I think says it perfectly. So, steroidogenesis is the process of taking cholesterol and converting it until you've got these critical hormones that we need to function and thrive. And as they say right here, steroidogenesis begins with the mobilization and movement of cholesterol from intracellular stores into the mitochondria. And hormone production, including cortisol, but also other steroid hormones, including testosterone, do not happen without the mitochondria. So if you've got a mitochondrial issue, that automatically means you have an adrenal problem, which automatically means now you've got abnormalities in cortisol, which typically means you've got this kind of a picture where you've got anxiety, child may feel depressed, may kind of be tired. They wake up groggy in the mornings, but they also have a hard time falling asleep. They're tired in the afternoons, but then get this second wind. They eat too many carbs and then they crash because their blood sugar is not stabilized because guess what controls blood sugar? Cortisol, right? So you get this funky picture. And why we get this funky picture is what wakes us up in the mornings? Cortisol, right? You need a big surge of cortisol in the mornings to get us up. So if this surge is not happening, what happens? You've got a kid who's just, right? They can't wake up, even though they've slept. And it's not because they're choking, gagging, and having trouble breathing. And when you look at, well, mycotoxins also trigger allergies and congestion, right? So you've got either a kid that does have some airway problems, but they also have adrenal issues, or they don't have airway problems, but their adrenal glands are not working well. And if you look at this curve, cortisol levels shouldn't really drop off until 8 to 9 o'clock, except if you've got a curve that kind of goes up and then poops out by 2 o'clock, what happens? You've got that kid or adult, and this is something that you can easily check your patients with. You've got the kid who struggles to get going in the mornings, finally gets going, but then by 2 to 4 o'clock is either tired, and you've got the 8-year-old that wants to take a nap, or they fall asleep in the car, or they're kind of tired, or crabby, right? Because some kids, and we'll talk about this in a second, some kids who have low cortisol actually express the low cortisol with irritability. And only for this to happen, for them to get a second wind. Why do they get a second wind? Because if cortisol drops too quickly, too fast, without the child falling asleep, you actually get a rebound. So what happens is at 6 p.m., 5 or 6 p.m., instead of getting this curve here, you get another curve that shows up here. And now there's a whole bunch of cortisol, plus or minus some other adrenaline-like compounds, norepinephrine, epinephrine, that actually causes the child to now be wired and have trouble falling asleep. What is this dark circle about? The body produces beta MSH, so melanocyte stimulating hormone, to actually augment the action of the adrenal gland. So it on top of histamine boosting cortisol, the other thing that is there to boost adrenal glands is this MSH, melanocyte stimulating hormone. It causes discoloration of the eyes because it is activating for whatever reason. I don't know why it's under the eyes, but it causes discoloration because this is where the effect of that hormone shows up. And a lot of families will find that the dark circles come and go because the effect of this melanocyte stimulating hormone is there briefly. I mean, some kids it's there chronically, but in other kids it comes and goes because these hormones are fluctuating. What you're seeing in real time is the physiological manifestation of that. Now, where does the crabbiness come in? So you have to ask, how does cortisol influence the nervous system? So it turns out that cortisol, as you see in this diagram, actually has a negative feedback loop on the HPA axis, the hypothalamic axis. So when there's sufficient cortisol, one, cortisol suppresses histamine, right? It has a really powerful antihistaminergic effect, right? So histamine is suppressed. On top of that, it actually creates a feedback loop into the nervous system, which downregulates the sympathetic response. So when adrenal glands are not functioning optimally, you get the HPA axis getting jacked up, which ultimately jacks up corticotropin releasing hormone, CRH, which then jacks up the sympathetic nervous system, which then jacks up the child. And if you pay very, very close attention, what you'll see is this is a pattern that shows its face over and over and over again. There are some plants that we'll talk about in the next discussion around how to help support the adrenal glands. But what I've also really become clear about is, well, if the adrenal glands are struggling because there's a mitochondrial issue, then wouldn't it be a smarter idea to address the mitochondrial issue? And if the mitochondria are struggling because there are toxins at play, then gosh, maybe the best thing to do is actually address those toxins. Because if you address the toxins, the mitochondria start functioning better, which also helps the nervous system light up, which also allows the adrenal glands to function more effectively. And collectively, you're also dropping histamine, you're also dropping microglial activation, and you're restoring the integrity of the entire system at once. So, do you see how critical it is to really have this big picture holistic view and not go charging into these individual systems, trying to micromanage everything, which oftentimes doesn't work nearly as well? What about nutrition? So, this is a really fascinating study. It's over almost 30 years old, where they ultimately looked at what do these toxins do to folate levels. So I can't even say it, fumonisins, which is the type of mycotoxins, increase risk of neural tube defects in offsprings by interfering with the folate binding protein and ultimately the ability to transport folate into the nervous system. And if you look over here, so these are basically toxins, right? The toxin levels of this fumonisin, right? And the higher the toxin levels go, this is folate, the lower the folate levels are. What do we see in kids with autism? Cerebral folate deficiency, right? And God bless the folks that have helped bring this awareness into our community. But how often do you hear conversations of why these kids have cerebral folate deficiency? Well, they have folate receptor antibodies. Okay, great. Where do those antibodies come from? We need to be asking these questions and getting to a place of understanding what's going on. And I can tell you that at least 60% of the kids that I see who have had mold toxicity have cerebral folate antibodies, to the point where I've stopped testing it and I just presume these kids have it. And I actually treat them with folate at a certain point in time because of that. But we fail to ask these questions and we jump and say, oh, this kid has cerebral folate antibodies. Let me just pump this kid full of folate while missing the bigger picture. These mycotoxins disrupt the villi. in the small bowels, which ultimately causes the ability of a child to absorb nutrients to be diminished. And with that, so this is primarily mycotoxins in food, primarily in animals, but what you see is reduced absorption of nutrients, inability to utilize the nutrients that are in the food, inability to digest crude protein, inability to transport amino acids. And you get this picture of ultimately realizing what happens to a child's ability to absorb all of these critical things they need for growth and functioning. You add to that what mycotoxins do to minerals. So, in animal studies, again, ochratoxin produced iron deficiency anemia. What do we see in these kids? If you've checked enough kids who have had mold exposure, my experience is somewhere around 30 to 50% of these kids are iron deficient. More of them are zinc deficient, probably 60 to 70% of them. Why are they deficient in these minerals? Yeah, you can give the kid iron, you can give the kid zinc, but what the hell is causing the deficiency? You get malabsorption of all of these different carotenoids. Yeah, you can give the kid a ton of whatever carotenoid that you like for antioxidant purposes, but if they're not absorbing it, God, isn't that a problem? And the last part is the part that's really troubling. So, vomitotoxin is another mycotoxin that's very common. And if you ever run the MyMyco lab where you're checking antibodies against the various toxins, you'll see the vomitotoxin regularly pop its ugly face there. So this mycotoxin caused moderate hypocalcemia because of decreased absorption. But if that wasn't bad enough, it ultimately affected the activity of the vitamin D hydroxylase, causing a decrease in vitamin D levels. What do we see in these kids who also have toxicity? Their vitamin D levels are in the tubes. And half the time, that's while they're in the sun in the summer. And again, we're chasing these levels saying, oh, well, this kid has vitamin D deficiency. Let me just give him 5,000 units of vitamin D without asking what the hell is causing it. And it's not one thing, right? It's never just, oh, this is just a mitochondria. It's never just, oh, this is one antioxidant. It's all of the collective impact, the full physiological impact. It's like a tank that rolls through a residential house and then flattens the house, and you wonder what happened. One of the things that I see in a lot of these kids, and frankly speaking, is one kind of red flag for me is these kids that pop up with like six cavities by the time they're 6 to 8 years old. And, people are like, oh, well, kids just get cavities. No, yeah. I mean, if the kid doesn't brush their tooth, yeah, one cavity, two cavities. Yeah. The kid that needs a root canal by the time they're 6 years of age, not normal. And why is that? Well, yeah, if you're not absorbing calcium and phosphorus, and you can see right there, inadequate supply of calcium and phosphorus minerals and inability for the gastrointestinal tract to absorb these minerals are important contributors to enamel hypoplasia. Now, they're talking about it in preterm children, and they're talking about it in the context of celiac. But guess what else messes up the gut and ultimately causes all of this? Mycotoxins. And all of this. So when you see this pattern where you've got a kid that's got learning disabilities, and oh yeah, he had five cavities by the time he was six, that should be a big red flag just right there. Those two data points. If nothing else, your brain needs to be thinking about when the hell was this kid exposed to mycotoxins? And what do I need to do to figure out how real this possibility is? In animal studies, what they've found is a lot of these animals that have been exposed, so TC is trichothecenes, that even at the lowest levels, these animals' food intake was decreased. And then you see in the bottom, in chronically exposed populations, their growth failed. So why is their growth failing? Let's go back and look at Let's see here. Let's see if I can find the right study. Sorry. Okay, so one of the things that happens is protein. There we go, right there, right there. Cytotoxic effect to the DNA and protein synthesis. It's not just that these kids can't absorb the nutrients. It's not just that they can't absorb the amino acids. It's not just that their appetite is suppressed. Whatever nutrients are actually getting into their bodies, they literally lack the ability to utilize them to produce the proteins and building structures they need to grow. And because of that, what do we see? We see this. And it's not just weight. A lot of times it's not the child is only in the first percentile of weight. Their height is exactly the same. And yes, some of these kids have growth hormone deficiencies, but I've also had a whole lot of kids who don't have a clear growth hormone deficiency, but there's obviously something very wrong. And when you test enough of these kids, you find they're iron deficiency, they're iron deficient, they're zinc deficient, oftentimes they're vitamin D deficient, and we don't understand what is causing all of that. If that wasn't disturbing enough, mycotoxins alter the brain chemistry through multiple different things in multiple brain regions, which can ultimately affect the secretion of the hormones that regulate appetite. Through increasing gene expression of anorexia-inducing pro-inflammatory cytokines, trichothecenes exacerbate the condition of anorexia. And then you can see it goes on. What do we see with these kids with autism? What do we see with these kids with PANS and PANDAS? Appetite suppression, right? I mean, some of them are going into frank anorexic states. And you can argue, and I don't have enough experience with anorexia to say for sure, but in my one or two cases of frank anorexia, I can tell you both of those kids had mold exposure. But we don't ask. We don't put two and two together, right? And forget about what histamine is doing. We're going to circle back to that as well. So you see all of these mechanisms that are at play. You see all of these things showing up in real life. And if you pay very close attention, you see all of these things happening, and they're all happening for a reason. We need to get to a place of understanding those reasons and understanding why they're taking place. And this is another study talking about the same thing. So mycotoxins are potent inhibitors of protein synthesis. In inhibiting their initiation, elongation, and ultimately completion of that entire thing. So when you see this in a patient, when you see that kid that's struggling to grow, don't just look at one thing. Don't just be like, oh, this kid has some zinc deficiency. This kid has some iron deficiency. Step way back and take all of these things that are actually happening, because this isn't a hypothetical event. These are not things that, I just pulled out of thin air. All of these studies I've put because I've seen this all in real life in multiple kids. And I would argue that most, if not all, kids who have failure to thrive have all of these processes unfolding in their physiology. And so far in the 10, max 20 kids that I've seen with failure, like severe failure to thrive, like 1 percentile, less than 1 percentile, all of them had mold exposure. All of them had mold exposure. And if you talk to enough people who have been in this world, they all say the same thing. Like, all of these kids have mold exposure. What else do these mycotoxins do? So it's not just the absorption, it's not just the utilization. Mycotoxins influence the growth hormone. So impairment of growth hormone axis via the cytokine signaling, which these mycotoxins induce. If you guys have followed Dr. Shoemaker, he talks about the secretion of MSH, which can ultimately influence all other pituitary hormones, and ultimately, the influence of serotonin, which can influence absorption of nutrients through the gut. It influences gut motility. So serotonin isn't just a happy chemical in our brain. Peripherally, it actually acts at a very important level to essentially regulate a lot of the gastrointestinal tract function, secretion of different kinds of fluids, absorption of nutrients, motility, et cetera, et cetera. This is where things get even more spooky. So it turns out that mycotoxins, especially fusarium, are profoundly estrogenic. So the most prominent mycotoxin that acts like an estrogen is fusarium, or the zearalenone that fusarium produces. So zearalenone is capable of binding and activating both human estrogen receptors due to its structural similarity to the body's own natural estrogen hormone. Now, why is that a big deal? So one, zearalenone has been observed to possess tumor-promoting activity because it's stimulating estrogen and hypothetically can induce the proliferation and carcinogenesis of estrogen-dependent tissue in the endometrium and cervix. But this is the other part of it. Like that's spooky and scary to sit and think about. And how many poor women have some kind of estrogenic tumor that is actually being driven by this. Because remember, mycotoxins also disrupt the immune system, right? We're going to touch on all of this. There's all kinds of other funky things that are happening. Zearalenone was also suspected to be the causative agent in some epidemics of precocious puberty, such as premature thelarchy and gynecomastia in young children in some countries. Every single case that I've had, and I haven't had hundreds, but every single case of precocious puberty that I have had in my practice, and I've had a few, all had mold toxicity as part of the picture. And it's not just the zearalenone, because when you add to that, there are some studies investigating the combined effect of all of the other players, such as BPA, phthalates, PCBs, dioxins. And when all of them, which we're all exposed to, right? All of these are sadly a very normal part of our exposome, right? We're all exposed to it. All kids are exposed to it. You add to that zearalenone on top of this, right? Fusarium shows up, dumps a bunch of zearalenone, which we inhale, and it could be in the food. That combined effect suggests that mycoestrogens may lead to adverse effects even at very low concentrations because of these synergistic interactions. This is really spooky stuff when you think about it and when you look at it. And if, again, just open your eyes and start looking in your patients, and you're going to see this in some of the older adolescents, what you'll find is their cycles are upside down. Those poor girls who are crying in pain for hours at the start of their menstruation, and they also have horrendous clotting and they have heavy bleeding and their cycles are upside down. These mycoestrogens are, if not playing a huge part, they're playing some part. And when you then zoom out, and these poor girls may also have fatigue, and they also have some brain fog, and the mom is having some issues, you start seeing the picture unfold in real life or real time. So let's talk about the immune system. They took some poor pregnant pigs, right? And they injected them with Dawn, which is a type of mycotoxin. And you can argue that inhalation of this may actually be more sinister, if not as bad. And they asked the question of, okay, if this pig is exposed to this toxin, what the hell does it do to the offspring? And again, this wasn't just in the food. This is actually now systemic exposure. So in pregnant pigs, at the end of their gestation, they found that there was altered mRNA expression of interferon gamma, interleukin 12 or 17-2, and TNF alpha in the leukocytes of the piglets. And it was sufficient to also decrease the population of T regulatory cells while also increasing the cytotoxic T cells in the piglets after birth. How many kids are being exposed in utero and they are being born into this world with this immune response already primed and ready to go? And we miss it. So why have I been so obsessive about helping you guys learn how to see it in the labs, how to identify it in the environment, to not miss it in the environment, to not have a parent tell you, oh, we tested our house, we don't have mold, therefore there's no mold. Why is that so important? Because if you miss that, you will miss all of this playing out in real time, and then you're struggling to figure out, why is this baby's immune system falling apart? You're struggling to figure out why the child's central nervous system is struggling, why their gut is falling apart. Prolonged exposure of mycotoxins in subtoxic concentrations can ultimately influence all of these inflammatory cascades. In non-cytotoxic concentrations, basically in minuscule amounts, can change the transcription of NF-kappa beta, which plays a very important role in our inflammatory cascade. If that wasn't bad enough, we've got these inflammasomes, NLRP3 being one of them, which has been very closely related to autism and all of the inflammatory processes that unfold in autism. You're welcome to go look it up. And it's also tied to all kinds of other inflammatory issues, neurological disorders. And the kick in the pants is candida lysine, which is you want to say toxin or a compound that candida produces when it's in its hyphae form, right? When it's kind of doing its thing, spreading everywhere. Candida lysine primes this entire cascade of inflammation. And then these mycotoxins pop into the picture and activate this inflammasome. And when that happens, essentially you get this entire cascade of inflammation that makes absolutely no sense. Why it's important to understand where a child's gut is, why we're looking at taking care of candida through some of compounds like nystatin, is because we're actually changing some of these things at the core level. Going back to the entire cancer discussion, you've got these estrogens that are floating around activating receptors. And simultaneously, you have essentially an immune suppressed state. When you look at certain things like mycophenolic acid, which they use for organ transplant, right? Mycophenolic acid they use for organ transplants, heart transplants, kidney transplants. That is a mycotoxin produced by penicillium. Cyclosporin, which they also use for transplant, is also derived from a fungus. And what they found is in certain animal studies, when they expose these animals to certain things like Stachybotrys, and S. chartarium is Stachybotrys being the classic black mold, what you get are pretty gnarly immune suppressed states. And in this case, I don't know how someone had the heart to do this skin graft in these animals, but they did. But one of the things that you'll see in your clinical practice is this picture. And you're going to see this stare you in the face if you see enough of these kids. And In my experience, 10 to 20% of the kids who have mold exposure have this. Sometimes it's not as pronounced as having a white blood cell count of 3,700. Sometimes it's like 4,900. Sometimes it's 5,000. But when you also pay very close attention to the absolute neutrophil count, what you find is that these kids have, in this case, it was just barely above their reference range. I've seen kids with an absolute neutrophil count of 800. And for any of you that worked in an oncology ward, those chemo kids hover between 500 to 800 when they're going through chemotherapy. Some of them, sadly get suppressed way below that. But some of these kids go into chemotherapy range of immune suppression, and we're missing it. And then we wonder why these kids are getting sick all the time. We wonder why these kids' immune systems are falling apart. This is how capable these toxins are of disrupting the entire physiology. And if you miss it, you're basically dead in the water. These mycotoxins are very good at disrupting the blood-brain barrier, and they're very good at disrupting it in very small amounts. And you can see T2 toxin, acute and prolonged exposure at very low concentrations compromise the blood-brain barrier. On top of the inflammatory response that they induce, mycotoxins can directly induce apoptosis. They can disrupt the neuronal cytoskeleton. They lead to demyelination. They disrupt neuroplasticity. They trigger weird effects in NMDA receptors to cause an excitatory effect. And this is the part that I think is most spooky. So this was an article by Dr. Campbell. They looked at 120 individuals that were exposed. So myelin basic protein. So these are all antibodies. Myelin associated glycoprotein, gangliocytes. You can see these are all antibodies against brain tissue. Antibodies against brain tissue because of these mycotoxins. And then just to go back, because we touched on this before, I think it's important to touch on it again to really help you put all of this together in one cohesive picture. Because when mycotoxins are at play and the gut is sufficiently disrupted, you now have all of this activation. And while the mycotoxins are causing a mess on their own, now the microglia show up and also disrupt neuroplasticity and connectivity and synaptic function and wiring, which then ultimately causes all kinds of weird changes to sensory pathways and impairment of processing of sensory information on top of the prefrontal cortex having issues with the GABAergic neurons, right? So you see how there's all of these physiological processes that are happening at the same time. And when they're compounded, this constellation of physiological factors then causes what? The child who's struggling to be in the world. You get disruption of the myelin sheath on top of the antibodies, on top of the direct effects of the mycotoxins. You get changes in glutamate signaling, changes in quinolinic acid on top of the effects of the mycotoxins. We touched on this before. Microglia also disrupt oxytocin. So you've got a kid who's emotionally disconnected in the world while completely overwhelmed by the world because of everything that's going on. They're having trouble managing the information flow from their environment, and we wonder why. You get changes in astrocytes because mast cells trigger astrocytes. Microglia, when they're activated, trigger astrocytes, which then changes further the glutamate homeostasis, changes the GABAergic activity in the nervous system, on top of the GABAergic interneurons in the prefrontal cortex not firing properly because you've got the mitochondrial issues, on top of the mycotoxin direct effect. So again, you see there's one hit after another, after another, after another, and there's like multiple physiological processes happening simultaneously, causing these kids to struggle, and we're missing the reason why. You get changes in the amygdala. We talked about this before, due to mast cell and microglial activation. So the kid's perception of the world is distorted. The kid's perception of what is a threat is distorted. They're overwhelmed. They're overexcited. They're toxic. And we call this autism. And those kids that flip out of their heads, that become aggressive, that become angry, that they're a threat to themselves or others. Where does anger come from? Fear. It's a very well-established psychological concept. Anger comes from fear. And when your perception of what is a threat in the world is distorted, you add enough neuroexcitatory compounds and whatever other constitutional things, you get an aggressive human being. I hope this picture becomes really clear to you, because once you start seeing this, it's really hard to not see it again, and you'll see it in so many patients. The microglia have also been tied to depression, and keep in mind that when the mitochondria are off, that impacts it. So first and foremost, when the microglia are activated, you get all kinds of vulnerabilities to psychiatric illnesses. But these studies are, I think, so fascinating and sobering. Microglia have been shown to play a crucial role in the genesis and course of depression. Microglial-derived neuroinflammation have been highly linked to depression. Significant microgliosis, microglial activation, has been observed in patients with depression who completed suicide. And how do most of our antidepressants probably work? By actually calming down the microglia, by calming down the inflammation, which is coming from these toxins, specifically the mycotoxins, specifically the endotoxins. And you add to this, it's not just a neuroinflammatory response. You add to this the mitochondrial abnormalities, because synaptic fatigue, if you go do a search for synaptic fatigue, that is tied to depression. And if you type in mitochondria and depression, you'll also see a plethora of studies talking about how mitochondrial abnormalities are tied to depression. And then you add to that the insufficiency of cortisol, and you look at some people who are depressed or tired, right? They're pooped. They struggle to get out of bed in the mornings. They're exhausted, but then they have a hard time falling asleep, right? They kind of drag themselves through the day, and then at nights they're just wired awake. Look at all of these pieces. Look at all of these different data points on your patients, and you will see these patterns keep showing their face over and over and over again. Microglial activation underpins the neurophysiology of ADHD. There's strong evidence that the development and function of the neurotransmitters that have to do with ADHD is tied to the microglial activation. And alterations in all of these different things are ultimately tied to that. Strong lines of evidence suggesting that OCD is a neuroinflammatory condition, and a specific role of the microglia in the pathophysiology of OSD has been demonstrated in at least some animal models. And what do we see in these kids, right? The kids that we label as pans and pandas, or the kids with autism, right? Or adults. It's never one thing, right? It's never just, oh, they're overwhelmed in the world. They also have OCD and they either look anxious or depressed or both, right? And when you look at the clinical presentation of these individuals, it's never one thing. It's never one thing. It's they have some OCD, they've got some ritualistic tendencies, and they've got some anxiety, and they're tired, and they're struggling to learn, and they've got this, right? And they've got some digestive issues, and they have some airway problems, and they have trouble falling asleep. And it's that total constellation that when you look at it, you're like, how do I make sense of this? Take the pieces and connect the dots, and you'll see those pieces come together. We had talked about histamine before. I want to bring it up again because I think, in light of everything, it's important to look at. Histamine influences our arousal centers. So, not only do you have a weird blip in cortisol, not only do you have too much glutamate floating around, which is neuroexcitatory in of itself, not only do we have neuroinflammation, you also now have histamine working against you. Not only do these individuals have cytokines that are disrupting their appetite centers. Not only do the mycotoxins directly disrupt appetite centers, you add to that, half these kids have some kind of form of nausea or they've got abdominal pain because they've got gastrointestinal inflammation from the mycotoxins. And then they also have abnormalities in histamine, which also influences their food intake. So you see all of these things going on. And the reason why it's so important to go after the root cause is if you don't go after the root cause, you will be spinning your wheels wondering why you can't get these kids well. Histamine can also cause an abnormality in our signaling of what is perceived as a danger, which drives anxiety. And this is on top of the changes to the amygdala. You get changes in sensory gating on top of the mitochondrial issues, which ultimately influence the prefrontal cortex, which then influences sensory gating. So again, it's never one thing, but it's all driven by the same thing. Histamine influences distortion of all of these different sensory pathways. You get sound sensitivity, you get lack of body awareness, and these kids are just clumsy. Motor planning is off. Their sense of smell is off. Their sense of touch is off. They have visual tracking errors and they're either struggling to read or they're bumping into things. On top of the fact that they're overwhelmed by the world, on top of the fact that their nervous system can't calm down, on top of the fact that their prefrontal cortex isn't working. So, do you see how this picture comes together? Do you see how this could look exactly like autism? And it's never one thing, right? It's never just the mycotoxins. It's the mycotoxins plus the endotoxins, plus some glyphosates, plus some other toxins that are there, plus processed foods, plus food colorings. And when you add that together, all of these things start making sense from these kids that have short-term memory issues. And some of these things were happening in me. I experienced half of these things. These were things that were happening to me. Changes in working memory. You struggle to learn math concepts. Why do some kids learn math concepts like it's nothing? And then other kids, 4 times 4 is 16. Johnny, what's 4 times 4? 12? This is the toxicity that's unfolding in their nervous system, and we are missing it. These mycotoxins cause mental confusion. And it's not a little bit of confusion, moderate to severe levels of cognitive challenges, various degrees of altered mental status, altered attention, blunted executive functioning, faulty short-term memory. All of these things are happening, and we are missing it. If you have a child who has weird motor tics or seizure-like abnormalities on top of everything else that we've talked about, you have to go looking for mold exposure. Children with long-term exposure to mold and mycotoxins have a 70% chance of having an abnormal EEG versus healthy controls. 40% abnormal visual evoke response. And why does that happen? So, upregulation of histamine receptors can destabilize the cortical striatal circuitry and contribute to tic pathophysiology. So, why do these kids just start ticking? Because of the histamine abnormalities. And another study, so it's not referring to number one, these results suggest that histamine is one of the key factors of Tourette syndrome, not just a little bit of tics, Tourette syndrome pathophysiology. All of these things show up in real life. And if you don't understand what they mean, these kids are going to continue to struggle and you wonder why you can't help them. So, with that, I thank you for taking the time to be a part of this conversation and to watch this presentation.